Okay, this is section 5.4 covering medians and altitudes in geometry. So we're going to start with medians first. Definition of a median is a segment that connects a vertex to the midpoint on the opposite side. Now, just like perpendicular bisectors and angle bisectors, medians are also concurrent lines. And the point of concurrency for medians is called the centroid. Okay, the medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint. So this distance right here, this is my centroid. I'm going to call it G. The distance from A to G is 2/3 of the entire length, which is A to D. Now, E is a midpoint, F is a midpoint, and D is a midpoint. So you want to put one tick mark around E, 2 tick marks around F, and then 3 ticks around D. Now you'll always have 3 medians. The median from A to D, the median connecting B to F, and the median connecting C to E. Now, we said that A to G is 2/3 of the entire length. So let's say that the length from A to D is 1 inch. Then that means that the length from A to G is 2/3 of 1, which is just 2/3. Then to find the length from G to D, that's going to be 1/3 of an inch. And the reason that is because 1 inch minus 2/3 of an inch is 1/3. Okay, let's try something a little bit more challenging. Let's say that the length from B to F is 6 centimeters. And I want you to find the length from B to G. So to find that length, you're going to take your total length and you need to multiply it by 2/3. So I take 6 times 2, which is 12, divided by 3. And you get 4 centimeters. So B to G is 4 centimeters. Well, what if I want you to find the length from G to F? Easy enough. You just take 6 centimeters minus 4 centimeters. And so it would be 2 centimeters. Now, if you notice, the length from B to G is twice as long as the length from G to F, and that's always going to be the case. So this right here is 2/3 of the entire length, but this length here is also double that of the length from the centroid to the midpoint. All right, let's go ahead and practice this. We're going to use this picture, and number 1, we know that RL, the entire length of the median, is 21 units. And we want to find the length of L to S, so this one right here. It also tells us that S to Q is 4 units. That does not help us on this problem, so you can cross that out. Well, I want to find the length from the vertex to the centroid, and that is 2/3 of the entire length. So you take 2/3 times the entire length. 2 times 21 is 42, and then divide that by 3. So you get 14. The length from L to S is 14 units. Now, what if I want you to find the length from S to R? I would just simply take the entire length as 21 minus this part, which is 14. And that would be 7 units. So you still see that this length, the vertex to the centroid, is double that of the centroid to the median, or to the midpoint. Number 2. It tells me RL is 21 units along, or 21 units again, and that S to Q is 4 units. I want to find the entire length of the median. Well, S to Q is 4. So if you know that the short length is 4, to find the length from the vertex to the centroid, you just double it. So that would be the length from N to S. Double 4, you get 8 units. So the entire length of the median, which is NQ, is going to be 4 plus 8, which is 12 units. Okay, number 3. We know that the length from the vertex to the centroid is 18 units. Now we want to find this length right here. So if the larger length is 18, this is going to cut, or that's going to be half as long as 18. So I just do 18 divided by 2. S to P then is 9 units long. Any questions? All right, let's talk about altitudes. The definition of an altitude is a perpendicular segment from the vertex to the opposite side. The altitude will show the height of a triangle. Okay. So here, if I want to know how tall this acute triangle is, this is the altitude, and that's what you would use to show the height. All right, the point of concurrency for altitudes, it's called the orthocenter. The orthocenter is going to be inside if you have an acute triangle. It'll be outside if you have an obtuse triangle, or if you have a right triangle, it's going to be on the triangle. And that is all the information you need to know about altitudes. So this concludes our notes for section 5.4.